This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on partial fraction decomposition. First, let's recall a rational function. A rational function is a function of the form polynomial over polynomial. So some examples that we could see would be like 3x over x plus 2, or x squared plus 4x plus 1 over x to the 5th plus x cubed, or 1 over x cubed plus 2x squared. Anything of the form polynomial over polynomial. So say we wanted to integrate one of these rational functions. For example, here we have the integral of 3x plus 5 over the quantity x plus 2 squared dx. For this particular example, there is a u substitution that would work, but it's a little tricky to apply, and we want to extend our method to more rational functions. So we're going to use a method called partial fraction decomposition that is going to help us get this rational function to a form that's a little easier to integrate. So we're going to take our rational function 3x plus 5 over the quantity x plus 2 squared. And the idea is we're going to split it up into the sum of fractions that are a little easier to integrate. So for this one, we're going to split it up into the form a over x plus 2 plus b over the quantity x plus 2 squared. And a and b are unknowns that we now have to solve for. So if I want to solve this equation, we're going to start by multiplying the entire equation by the common denominator, which in this case is x plus 2 quantity squared. If we do that, on the left side, we're just going to be left with the numerator, 3x plus 5, equals. The first term on the right, we have a over x plus 2 times the quantity x plus 2 squared. So one of those x plus 2's is going to cancel, and it's going to leave us with a times x plus 2 plus, for our second term on the right, the x plus 2 squared are going to cancel, and we're just going to have b. Now I'm going to simplify my right side. I'm going to say 3x plus 5. We'll distribute this a in, and I have ax plus 2a plus b. Now, to solve for a and b, we're going to use a technique called equating coefficients. So notice, in these two expressions, they're equal, and on the left I have 3x's, and on the right I have ax's. So if these are really equal, then a must be 3. We have to have the same number of x's on either side. So we have a equals 3. Okay, that's one of our unknowns. We also need to solve for b. So using the same idea, on the left we have 5, and on the right we have 2a plus b. And if these are equal, then 2a plus b must equal 5. We already said that a is 3, so this is 6 plus b equals 5, which tells us that b is -1. Now we've solved for both those unknowns, so let's go back and rewrite our decomposition. So we said 3x plus 5 over the quantity x plus 2 squared equals a over x plus 2, and a is 3, so we have 3 over x plus 2, plus b over x plus 2 squared, and b is -1, so -1 over x plus 2 quantity squared. And this is our partial fraction decomposition. Now those rational functions on the right side are going to be a little easier to integrate. So let's go ahead and try to integrate now. So now if we want to integrate, we know that the integral of 3x plus 5 over the quantity x plus 2 squared dx is equal to the integral of 3 over x plus 2 plus -1 over the quantity x plus 2 squared with respect to x. And since the integral is a linear function, we can separate these and do the integral of 3 over x plus 2 dx plus the integral of -1 over x plus 2 squared dx. And we can do these calculations to end up with 3 times the natural log of x plus 2 plus 1 over x plus 2 plus our constant of integration. And that's how we can use the method of partial fraction decomposition to help take the integral of rational functions.